So this second video on inequalities carries on from the last one. So this should be the last question you looked at, number 4. Let's look at some combined inequalities now. So let's look at, for example, x between the values of 3 and 5. Okay, so 3 less than x, less than or equal to 5, and how we would write this on a number line. So this is a combination of both. It should make sense. Let's draw a number line. Nice straight line drawn. Obviously, we're only dealing with positive values here, so I can tweak my number line slightly. So maybe I'll put 0 down here. Just so we can go a little bit higher up. And we still have a couple of negative ones just for good measure. So there's our number line. So this combined inequality here, x is sandwiched between 3 and 5. So it's exactly the same kind of idea on the number line, and that's how we need to think about this. X can take any value. We've got, if we think about this kind of part, we want x bigger than 3, so anything this side of 3. But we also want the other part, if we forget that bit, we want x less than or equal to 5, so we want x being any value less than or equal to 5. So it's a combination of x being greater than 3 and less than or equal to 5, so it's sandwiched between 3 and 5. So we treat this as the same way on our inequality on our number line. So at 3 we want x bigger than 3, so we have an open circle at 3 because of this bit. This is strictly greater than 3. And we'll have everything kind of going that way, but we've also got an endpoint this time because x is also less than or equal to 5. So we want a closed circle at 5. It's including less than or equal to 5. And we want all the values between 3 and 5. So we would get our ruler out and this time connect our two circles. Hopefully more neatly than me. Something like this. And that shows that x can have any value that is bigger than 3, which is going this way, but also I've got to be less than or equal to 5, so that sandwiches it between these two values. Okay, so it's kind of how it looks. It looks like x is between 3 and 5, so we can have any value between 3 and 5, including 5 because of the equal to bit. So we can have any value bigger than 3, less than or equal to 5. Open circle here because of the strict inequality there, and a closed circle here because of the equal to inequality here. Let's do another one. So this time -1 less than or equal to x less than or equal to 2. So number line goes in, 0, and then numbers either side. Make sure you include the numbers, obviously. We've got here, otherwise we won't be able to display them. A lot of the time they will draw the number line for you, but it's good to be able to think about it yourself. So in this one we want x sandwiched between -1 and 2. So we want x bigger than or equal to -1. Remember the open bit of the inequality means bigger than. So we want all the values bigger than or equal to -1. So find -1 is equal to, so it's going to be coloured in. But x must also be less than 2. So we find 2, open circle at 2, because we can't include 2 because there's no equal to, there's no little line underneath here. We want x sandwiched between those two values. Sorry. X sandwiched between those two values. So, it seems to have disappeared. So, equal to here. An open circle here. Sandwiched between the two values, so connect the two. Sorry, my OneNote closed unexpectedly. So connect them, and then that shows that we can have any value that's bigger than or equal to -1, and any value that is less than 2, but not including 2, hence the open circle there. So they're combined inequalities, and then we can also have what we call split inequalities. So let's look at when we have x bigger than 2 also x less than or equal to -3, and how we write this on our number line. So this is split. We can't write this. Inequalities always have to follow this way. We never write inequalities the other way around. Okay, it just doesn't make sense because we can't put a big value here and a small value here because it doesn't make sense. Like we'd always put that because of the direction of a number line. But this doesn't really make sense as an inequality. So they're always chasing each other, the little crocodile mouths. They're always chasing each other this way. If they can't chase each other, so I can't say, oh, x bigger than 2 like this one and less than or equal to -3, because then 2 effectively is less than -3, which is absolute rubbish. So we can't have that. So we always put the smaller value on the left. So there's no way we can write this without having it as split. Okay, and you'll see that on the number line when we draw the number line. So we're going to do this as two kind of inequalities on one number line here. So there's our straight line, 0, 1, 2, 3, blah, de blah. And then label up. And again, it should be easier for you. You've got a rule, you can measure it. And then we just draw these split. So x greater than 2, we want all the values greater than, strictly greater than 2. So open circle at 2, and then a line showing all the values bigger than 2. And you should be able to see x less than or equal to -3. We'll find -3, it's a closed circle because it's got the equal to bit in it. And we want all the values less than that. So therefore we want all these values this way. So you can see that it is a split inequality. Okay, the values split, it's not continuous. Sorry, I'll do again towards, when I do this I extend it to the end, so right to the end of the number line, right to the end of the number line, but this is clearly split. X cannot be both bigger than 2, like 5, and less than or equal to -3. It can't happen. So this is a split inequality defined with two separate things. Hence we have a split. It's not continuous. This is what we call a continuous interval because there's no break. We can go from -1 to 2 and there's no break between those values. But here, if I want less than or equal to -3, that's here. But then -2, this -2 here, sorry, in this spot, it's not less than or equal to 3. -3, sorry, it's bigger than -3, and also it's not greater than 2, so it wouldn't be an inequality. So we've got two separate parts of this inequality, what we call a split inequality. Let's do another one of those. So this time x less than -1, x greater than or equal to, let's go 4. So again, number line. There's 0, 1, 2, 3. There's our number line. So we're split, so we want this as one part, so x less than -1. So find -1, we want an open circle there. Because it's a strict inequality, there's no equal to bit underneath it, so it's an open circle. We want all the values less than -1. So that's everything this way, right to the end. Oh dear, my line's not very good there. It's easier to change the circle. So everything less than -1 is this. And then x bigger than or equal to 4. Equal to, so we draw a closed circle at 4, and I'll just cheat. Oh no, it looks bad. I'll do a straight line with a ruler. So which I'm a lot worse at. We'll get there. There we go. It's not bad. X bigger than or equal to 4, so any value bigger than or equal to 4. Okay, so this is split. X can't take all those values at the same time, so it splits these two values. So either x is bigger than or equal to 4, so this is like an OR. can't be both at the same time, or it's less than -1. Okay, we'll talk about how these kind of values can come about from equations in future videos. But that's how we represent all our kind of inequalities on a number line. So there's 2 videos. First one kind of explains inequalities, and then the second, the end of that and this one, explains some of the slightly more tricky ones and how to represent these on a number line. In the next video, we'll look at representing them on graphs and solving equations. I say solving equations, I mean solving inequalities, but they're kind of like equations, so we'll do that as well.